Welcome to part 8 in this series of videos where I create a Blazor application to calculate the area of walls I need to tile for a particular room. This is designed, amongst other things, to demonstrate the use of cascading grids. At this stage we have a functioning wall area calculator, but it doesn't take into account the area we don't need to tile because of doors and windows. I'm calling these areas deductions. We will add a grid for deductions. Each item, such as a door or window, will be a distinct deduction. To make life a little easier for me, I will assume that each deduction is rectangular. The deductions grid will have a toolbar allowing for the addition, edit and deletion of individual deductions. The toolbar buttons for adding and editing a deduction will open a dialog inviting the user to enter a description for the deduction together with the height and width. The crucial aspect of adding, editing and deleting a deduction is that the area of the wall associated with the deduction will need to be recalculated. So let's have a look at the code. This is where we left off in the last video, where we created a method to calculate the area. We'll start by adding a grid for the deductions. This is going to follow the pattern used for rooms and walls. And I'm not going to go into a great deal of detail for this, other than to say it follows the existing patterns we've already established. So I want a grid after walls. So I'll put it down here. And this is the code we need for the deductions grid. It uses a data source called deductions. We're using a toolbar which is called deduction toolbar items. And we've got some other items we'll need to declare down here. I'll come back to some of this in a little while, but basically we've got two columns, a deduction name and the square meter. So it could be window and 1.0 square meters. As we can see, this has introduced a number of variables that we'll need to declare. And the first of these is an IEnumerable for the deductions. So I'm going to just go down to the declarations area and add it in here. We also need to add the deduction toolbar items. So in the declarations section, I'll declare a list for the deductions toolbar items. And I'll put it under the other toolbar items. And on the initialized async method, we need to add in the code for the toolbar items there. So this again follows exactly the same pattern that we've used before for toolbar items. As with the other grids, we'll need a toolbar click handler and a row select handler. So I'm going to add two methods just before the region for calculating the area. And I'll do that down at the bottom of the code, before the area calculation region. And again, I'm going to enclose this in a region so we can collapse and expand it as we need. And again, we've introduced some more variables. The first thing we're going to need to do is to inject the deduction service, which we've already created at the very beginning. So we'll put that at the top of the code. And we're going to be using a dialog to enter details of deductions, and we'll be using an object of type deduction to hold data when adding or deleting a deduction. We need to add declarations for the dialog and the deductions object. So let's do this in the declarations section. And I'm going to collapse some of these as I go. So we'll put the dialog for the deductions and the deduction object down here, again in the logical sequence. And we're going to need to hold some data about a deduction when selected. And I'm jumping ahead a little bit, but we'll need variables for these as well. So I'm going to put those down here. So it follows the similar pattern for walls. We're going to be getting various information from the grid and holding those in variables. And in the dialog, which we haven't added yet, the user will be entering the height and width of the deduction in millimeters. And these are going to be stored in the database as integers, whereas the area will be calculated in square meters, and that's going to be a decimal type. We therefore need to convert the height and width from integers to decimals before doing the calculations. To do this, we also need to declare new variables of decimal type to hold the height and width of deductions. So again, more variables to be declared. So a decimal type for the width and a decimal type for the deduction height. I'm now going to go back to the deductions grid. And we're going to be recording the height and width of the deduction, as I say, in millimeters. And we want to show the area of the deduction in square meters. The database will not record the area, but instead we will calculate the square meters from the height and width whenever it is needed. Looking at the code for the square meters column, we've got this. So we've got the column, so it's going to be called area of square meters. It's going to be aligned right. I've said the format is N3, but I'll come to that in a second. And the width is going to be 20 units, or 20%. Now what we've got to do the calculation is have this section in a template. And we declare a var value, and the context is deduction. Then we convert our integers for deduction width and deduction height into decimals, and then we do the calculation. So the square meter is around deduction width times deduction height divided by 1,000,000, because there are 1,000,000 square millimeters in a square meter. We round to 3 decimal places, and as discussed last time, we're going to use midpoint rounding away from 0. But this is the bit that caused me the most trouble. I wanted to display the square meter to 3 decimal places, and I found that by putting format equals N3 did not do this. It did format it correctly if we had 3 decimal places, but if we had trailing zeros, it didn't display the trailing zeros. And eventually I discovered the way to solve this thanks to the Syncfusion forum and help desk. And I should add here that they responded very swiftly to my inquiry. We converted to a string, and then we put this F3 in quotes, and that will format it to 3 decimal places. I don't think I actually need this format equals N3 up here at all now. But anyway, that's how this is displayed to 3 decimal places. Whenever we need to populate the deductions grid, we only need those deductions associated with the wall selected at that point in time. We therefore need to add a new method to the deduction service that I'm going to call deductions read by wall. So if we go to the deduction service, and I want to introduce a new service here. We've got deductions read all, and I want a new one which is just called deductions read by wall, and this is it. It follows exactly the pattern we've used elsewhere. So we've got an IEnumerable of type deduction, and I'm calling it deductions read by wall. I'm going to be passing into it the wall ID. We define our parameters, we define the SQL command, and then we carry out the SQL command. This is using SQLite and Dapper, and we'll return the deductions. And of course, having done that, we need to update the interface. And for that, we need this line, task IEnumerable deductions read by wall, and then integer wall ID. If we go back to index now, we should find that we've got no errors. So although the grid won't work, it might be worth saving all the files and running the application, so long as we don't try to enter any deductions. So let's try that. Right, well, here's our application. We can select a project, we can select a room, we can select a wall, and here's our deductions grid. As I say, we've got the toolbar, and we've got the grid, and we've got the headers there, but we haven't got any data. So let's look at creating the data for this. We haven't added the dialog yet that will allow the user to add and edit deductions. So we're going to insert some code after the wall dialog. This simply follows the pattern we've used before, with 3 text boxes, the deduction name or description, the deduction width, and the deduction height. It uses 2 new methods, one for saving a record and one for cancelling. So we need to enter these new methods at the end of the deductions code region. So we've got deduction save. If it's an insert, we use deduction create. If it's an edit, we use deduction update. And then in all cases, we refresh the deductions object for the particular wall that we've already selected. And we also update the walls. And I'll come to that a little bit later. But the reason we do that is that the net area of the wall will obviously be affected by the deductions we've just added or edited. As I say, the above allows us to add, edit and delete deductions. But when initially selecting a wall, the deductions for that wall are not displayed. And similarly, after adding a deduction and reselecting another wall, or indeed a room or project, the deductions grid is not refreshed to reflect the newly selected wall, room or project. To correct this, we need to refresh the deductions object whenever a wall is selected and set the deductions object to an empty object whenever a project or room is selected. To refresh the deductions grid whenever a wall is selected, we need to make changes to the wall row select handler. So if I can find that, the wall row select handler, we need to add this. We want to get the deductions for the selected wall. So we're passing into the deduction service, deductions read by wall with the selected wall ID, and then saying status change to force the change. And to set the deductions to an empty object, following the change of a project or room, we need to add these to the onChange project and room select handler. So onChange project, I'm going to use find and replace to find that. So we already have here, whenever we select a project, we're emptying the walls. Now we do the same for deductions. And we also want it on room row select handler. In fact, at this stage, it would be worth reviewing what should be updated when projects, rooms and walls are selected, added, updated or deleted. To spare you the pain of watching me make all these changes, these are the changes I think we need to at least review. So on a change of project, the rooms grid will need to be refreshed to show rooms for the selected project. The walls grid will need to be cleared and the deductions grid will need to be cleared. And the code for this is on the on-change project, which we've just done. So the rooms is updated to get the rooms for the selected project and the walls and deductions are emptied. On the room row select handler, the walls grid needs to be refreshed to show the walls for the selected room and the deductions grid cleared. And the code for this is on the room row select handler, and this is the code. When the room toolbar click handler is selected, if a room is added, this is done under the room save method. The rooms grid needs to be refreshed, the walls grid needs to be cleared, and the deduction grid cleared. If a room is edited, the rooms grid needs to be refreshed and we don't need to touch the walls or the deductions. If a room is deleted, the room grid needs to be refreshed, the wall grid cleared and the deductions grid cleared. So the code for these three items is on the room save. When we're creating a room, we've got the rooms, walls and deductions changed here. On a room edit, we just need to get the rooms for that selected project. If the room is deleted, we need to refresh the data grid for rooms to reflect the missing room, and the walls and deduction grids need to be emptied. In the case of the wall row select handler, the deduction grid needs to be refreshed to show deductions for the selected wall. And that's simply what we've just done. Under the wall row select handler, we're just getting the deductions for that particular wall. When the wall toolbar click handler event happens, such as a wall being added, which will happen under the wall save method, or wall edited, again, which will happen under the wall save method, or wall deleted, we need to do the following. If it's a wall added, we need to refresh the grid, the walls grid, and then we need to clear any deductions. If a wall is edited, we just need to update the walls grid, i.e. the deductions will just stay the same. If we edit a wall, nothing will happen there. And if a wall is deleted, the walls grid needs to be cleared and obviously the deductions grid cleared as well. And the code for this, for the wall save, if it's an insert, we just need to update the walls and the deductions objects. If it's an edit, we just need to update the walls. And if a wall is deleted, we need to update the walls for the selected room and clear the deductions grid. Lastly, we've got to think about what happens when we use the deduction toolbar click handler. So if a deduction is added, that will happen under deduction save. The deductions grid will need to be refreshed, but what is most important is that the walls grid will also need to be refreshed. And this is a variation that we haven't come across before, where we're updating a parent grid when something happens to a child grid. So when a deduction, for example, is added, the net area for the wall, which is in the grid above, will need to be updated. So we need this wall grid to be refreshed. Similarly, if a deduction is edited, The deduction grid needs to be refreshed, but also the walls grid needs to be refreshed to reflect any change in the deduction. And lastly, if a deduction is deleted, the deduction grid needs to be refreshed to remove it, but also the wall grid needs to be refreshed to reflect the updated net area. For deduction save, in the case of both adding and editing, we need to update the deductions and walls. And if it's a delete, again, we just need to update the grids for the deductions and walls. So I think that concludes the review of that. I will make all the changes to the code to reflect what I've just said here. Well, that turned out to be a lot more extensive than I first thought, although we had already covered some of the above. Note that whenever deductions are added, edited or deleted, we need to refresh the wall grid. This is because the wall area needs to be recalculated whenever there are changes to deductions, but we'll come to that shortly. At this stage, I just want to save the files and check that the system still operates and that the behaviour is as expected. So I can select a project, select a room, select a wall, and I should be able to add a deduction. And we've got our deduction here, but notice that it didn't change the area of the wall. So let me just select that and edit it. Let's make it a door. That all seems to work. If I add a new wall, we find that the deductions grid is cleared. So I think what we want to happen has happened. So the next stage is to look at amending the wall area calculation to include the deductions. Whenever a deduction is added, amended or deleted, the net area of the associated wall will need to be recalculated. There is also the other situation where the area of a wall will need to be recalculated, taking into account deductions, and that is if an existing wall is edited. When adding a wall, there will obviously be no deductions at the point it is saved, and if deleting a wall, all associated deductions will be deleted thanks to the cascading delete on the database. We could have separate methods for calculating the net wall area depending on the action being performed. But it would be neater if we had just one overall method that could be called in all situations. We'll start by looking at the existing area calculation method. This is currently called by the wall save method and passes the wall object, wall add edit, to the method, calculating the area of the wall, passing back the wall add edit object, updated with the wall square meters, to the wall save method, allowing the wall to be saved, both for insert and edit. Unfortunately, this will not work as it is for adding, editing and deleting deductions, because the wall add edit object is not available to the deduction save method or to the delete option in the deduction toolbar click handler. Instead, for these actions we have the selected wall ID, and we can therefore use that to get the data for the wall we need. The strategy we will use for calculating or recalculating the area of a wall in all cases is therefore to calculate the gross area of the wall, get a collection of all deductions for the specific wall, cycle through these, calculating the area of each deduction and adding it to a cumulative deduction total for the wall. We will then calculate the net area of the wall by calculating the wall area and deducting the total deductions. For a new wall, there is a slight wrinkle we can exploit. The wall ID is 0 for a new wall until it has been saved. And because it is a new wall, therefore it cannot have any deductions, so we can omit that part of the procedure. Where calculate area is called from wall save, the wall add edit object is effectively passed back to wall save with the wall square meters updated. Where calculate area is called from wall save, the wall add edit object is effectively passed back to wall save with the square meters updated. Down here. Ready for the wall to be saved as normal. Where calculate area is called from one of the deduction events, we will need a new service to update the relevant wall record with the updated square meters. We will call this wall service wall update area. So let's go to the wall service and insert this new method. And we'll put it after the wall update. So wall update area, and we're passing to it the wall ID and the area, and then we're simply updating it. This will of course require an update to the iWall service. So I'll insert the interface there. And back in index.razor, we need to consider 3 topics: wall save, deduction save, and the calculate area method. These are all interlinked and there's no simple starting point, but I've decided to start with calculate area. The first thing to do is to change the parameters being passed to it. For wall save, we have wall add edit available, but for deductions, we only have the selected wall ID. So the first change is to change the method. And we'll do this by basically adding this new parameter called selected wall ID. It will be helpful to distinguish whether the method has been called by wall save or one of the deduction save or delete options. The way I have chosen to accomplish this is to set the selected wall ID parameter to 0 if the method is called by wall save. Conversely, if the method is called by deduction save or deduction delete, the wall add edit object will be empty, but selected wall ID will be non-zero. We'll start by checking to see if the method has been called by deduction save. If it has been, we will need to populate wall add edit with the data for the associated wall. So at the top of the code, I want to insert this. So if coming from wall save, wall add edit will be populated, or if coming from deductions, wall add edit will be empty, but selected wall ID will be non-zero. So we need to populate the wall add edit if using selected wall ID. So if selected wall ID is not 0, wall add edit will use this new service called wall read 1. So we now need to add that to the wall service. And I guess we'll have it after read by room. So we pass into it a wall ID and it gets everything for that particular wall. So of course we also need to update the service. And we'll put it there. So back in index, with the wall add edit object populated, we can use the existing code to calculate the gross area. And once we have the gross area, we can then calculate the total deductions for the wall. And to do this, I can add some code after this. After we've calculated the gross area of the wall, we want to get the deductions. So we set our a variable called deduction total to 0. This will be the cumulative. If the wall add edit is non-zero, we'll get the deductions for that particular wall. We'll cycle through them, accumulating wall deduction total. And that's not where that should be. That should be here. We want to do the division before the rounding. Sorry, got distracted there. So we'll cycle through here, calculating the cumulative deductions, and then subtract that from the gross wall area. In the above, we start by initializing a variable called wall deduction total. If calculate area has been called by wall save, the updated wall add edit object will be handed back to the calling method as previously, but if calculate area has been called by one of the deduction events, we need to update the wall record directly at this point. So we can do that by adding the following code here. So if the selected wall ID is non-zero, we call the wall update area, passing to it the wall ID and the wall square meters. So our completed code for the calculation is, if necessary, get a wall add edit object, otherwise it's passed in. Calculate the gross area, calculate the deductions if necessary. If necessary, hand back wall add edit to wall save, otherwise update the wall area directly here. It's a little bit convoluted, but it should work. Now, as we've changed the calculate area, we need to change wall save to accommodate these changes. In fact, it's simply a matter of adding the additional parameter for selected wall ID to wall save, setting it to 0. So at the top of wall save, we need to change this to put in 0. That will indicate that it's coming from wall save rather than from one of the deduction methods. Now on deduction save, we can't place the call to calculate the wall area at the top of deduction save. Rather, we have to wait until the deduction has been saved. So we need to add some code immediately after creating or updating the deduction. So what we want to do is, after creating a deduction or updating a deduction, we want to calculate the area here. So we always do the area calculation. Wall add edit is going to be empty, but we will have the selected wall ID. And similarly for deleting a deduction, here we have the toolbar handler for deduction and delete. Before refreshing the grid, we want to do the calculation. And again, we'll be passing in the selected wall ID. That, I think, should do it. So we'll save the files and we'll run it. Right, so select a project, select a room. I'm starting off with clean data here, so I'll swiftly add a wall. And we get an area of 6 square meters. With that wall selected, we can now add a deduction. Let's call it a door. the area of that should be 1500, 1.5 square meters, and we should see that area drop down to 4.5. And it does. If we edit the wall and make it bigger, we should see the area updated, as indeed it is. And if we edit the deduction, let's make that 1 meter wide. So the total area of deduction is 2 square meters, and that has also got updated. So let's just double check. We'll delete that. The area should go up by 2 square meters, and it does. So I think we're fairly safe that everything is now working. I'll put links in the description of the video to a blog post where you can get a transcript effectively of this video and all the code, and I'll also put a GitHub link in so you can download the code for the entire project. Apologies, this has been a bit of a marathon, and particularly for the time it's taken for me to produce this last video. Thank you very much for watching, and I hope you found this video of interest. Thank you very much.